We're given the graph of the first derivative function and asked to indicate when the first derivative is positive or negative, then indicate the number of critical numbers and any relative extrema. So again, it's important to recognize that this is the graph of the derivative function, not f of x. But when we finish answering these questions, we will compare f of x with f prime of x. So it first has to determine when the first derivative is positive and when it's negative. Well, a function is positive when it's above the x-axis, and it's negative when it's below the x-axis. So f prime of x would be greater than 0 or positive over this interval here and over this interval here. And notice how f prime of x would be negative over this interval and over this interval. So f prime of x is greater than 0 or positive over the open interval from -5 to -1, but also from 2 to infinity. Remember, if the first derivative is positive, this indicates that the function f of x would be increasing. And the first derivative is less than 0 or negative over the interval on the left, which would be from -infinity to -5, as well as the open interval from -1 to 2. If the first derivative is less than 0 or negative, this indicates that the function f of x would be decreasing. Next, we're asked to find the number of critical numbers. Critical numbers occur where the first derivative is undefined or equal to 0. Well, we can see that the first derivative is a polynomial function, so it's never undefined, but it is equal to 0 here at x equals -5, here at x equals -1, and here at x equals +2. So there are three critical numbers, and they are x equals, again, -5, x equals -1, and x equals +2. And now we're asked to determine the location of any relative extrema. If we go back over to the graph for a moment, notice how the first derivative changes from negative to positive at x equals -5, and it changes from positive to negative at x equals -1, and then from negative back to positive again at x equals +2. Well, if the first derivative changes from negative to positive at x equals -5, that means the function f of x changes from decreasing to increasing at x equals -5, which means f of x would have a low point and therefore a relative minimum at x equals -5. So there's a relative minimum at x equals -5, and then because the first derivative changes from positive to negative at x equals -1, f of x changes from increasing to decreasing at x equals -1, and therefore f of x has a high point or a relative maximum at x equals -1. And then finally, notice at x equals 2, the first derivative changes from negative to positive, which means f of x again changes from decreasing to increasing at x equals 2. Therefore, f of x has a low point, and there's another relative minimum at x equals 2. So there's a relative minimum at x equals -5 and at x equals +2. Now let's compare the graph of f prime of x and f of x on the same coordinate plane. We have the graph of the derivative function in blue and the graph of the function f of x in red. So first notice where the derivative function is positive, here and here, the red function is increasing, here and here. And where the derivative function is negative, here and here, the function f of x is decreasing, here and here. And notice that the critical numbers, -5, -1, and +2, f of x has a relative minimum at x equals negative 5. F of x has a relative maximum at x equals negative 1. And f of x has a relative minimum at x equals positive 2. I hope you found this helpful.